Hey guys, this is homework help for geometry lesson 2.1, questions 7 through 12. So in lesson 2.1, we've been looking for patterns and trying to extend those patterns and explain those patterns. So number 7, they drew us a picture, and we have this diagram here that has 1, 2, 3, 4, 5, 6, 7, 8 triangles kind of pieced together. In the next diagram, we've got 1, 2, 3, 4 triangles pieced together. And the last one, we have 2 triangles pieced together. And they ask us to draw sorry about that. They ask us to draw the next picture, the next figure. So as we see, this kind of takes the middle of this, and it's half, 8 to 4 to 2. So half of 2 is going to be just the one triangle. Okay. Number 8. Ryan is playing with his Hot Wheels. He races his red dragster car against his blue convertible car 3 times using race courses of different lengths. What conjecture can you make using the information in the table below? So race 1, the red car beat the blue car 5 seconds to 7 seconds. On racetrack 2, the red car beat the blue car 4 to 6.5 seconds. And in racetrack 3, looks like the red car beat the blue car 6.5 seconds to 8 seconds. So what kind of conjecture or what kind of conclusions can we make from that? We can say that pretty confidently that red car is faster. Red car is faster. Okay. Since from racetrack 1 to racetrack 2, both of the times decreased, we could say that racetrack 2 is shorter or somehow faster, right? Maybe it's got dips in it or something that makes it go faster, but usually it's flat and they're just shorter. And then racetrack 3, I'm sorry, is faster. Let's put than racetrack 1, okay? Because otherwise we're saying faster, then we don't say anything. And then if I look at racetrack 3 compared to racetrack 1, both of the times are longer. So over here, I'm going to scoop this over a little bit. I'm going to put for my last conjecture that racetrack 3 is longer or slower, because both cars had a slower time. So longer or slower than racetrack 1. Okay, so my 3, and I apologize for that handwriting, that was pretty bad. So my 3 conjectures that I'm going to try to make is that the red race car is faster than the blue. Okay, I should have finished that sentence probably. The second conjecture is that racetrack 2 is shorter or faster than racetrack 1. And the third conjecture that I made was that racetrack 3 is longer or slower than racetrack 1. Okay, let's go ahead and flip our page and look at number 9. Okay, Jessica wrote the number pattern below 3, 5, 9, 15. She noticed another pattern when she formed the difference between consecutive numbers decreased by 2 is shown below. So from 3 to 5, it was plus 2. And then from 5 to 4 is plus 4. And then from 9 to 15 is plus 6. If the difference continues to increase by 2, what will the 6th and 7th terms of the original pattern? Okay, so we do plus 2, plus 4, plus 6. This one's going to be plus 8. So 15 plus 8 is 23. Okay, and then 23 plus what we're going to add to this one. So if it increases by 2 each time, this one's also going to increase by 2. So 23 plus 10 is going to give us 33. Okay, so if I look, I'm sorry. Oh, the sixth and seventh term. So let's check. This is term 1, term 2, term 3, 4, 5, and 6. So that was really tricky because on the front page they asked us to find the next two numbers or the next two terms. And in this one they said the sixth and seventh terms. So that's going to be, this is sixth is 33. So I know it's either going to be A or C. So I'm going to mark those out because I know it's not going to be those. But if I had not reread that direction, I would have went ahead and went with 23 and 33, which was letter B, which would have been wrong. Okay, so don't let, make sure you're reading the problem and not missing them because the way they worded them or because they tricked us. So if this one increased by 8, this one by 10, the next one's going to increase by 12. So I have 33 plus 12, which is going to be 45. And that's going to be the seventh term. Okay, so the sixth and seventh term, here's the sixth term, here's the seventh term, is 33 and 45. So it's going to be A. Okay. Numbers 10, 11, and 12 have to do with solving equations, have to go back to algebra. Okay, so we're going to go ahead and work those out. I may rewrite this on another paper so that I have big room to write, okay? Pardon me for just a second. Okay, so it's going to be, I'm going to write a little bigger so it's easier to see. 4 minus 12x equals 10 minus 18x, okay? So I'm going to draw my line here where my equal sign is. I'm going to decide which side's going to be my variable side and which side's going to be my number side or my constant side. So since this has positive variables, I'm going to make this my variable side and this my number side. The variables I have on the number side, I'm going to add the opposite so I can move them to the variable side. The numbers that I have on the variable side, I'm going to add the opposite so I can move them to the number side. And then I'm going to solve by multiplying or dividing. So this is the number side and I have negative 12x, so I'm going to go positive 12x because that's going to go to 0, and I'm going to go positive 12x and I'm going to put it with the 8x because they go together. They're both just x's. So if I add those together, I get 20x. So I have 40 equals 10 plus 20x. I still have numbers on my variable side, so I'm going to add the opposite so I can get rid of those. So I'm going to, hang on a second. Okay, so I had to take a time out there to relook at the problem because something didn't quite look right. So when I rewrote down the problem, I wrote it down wrong. So the problem said 40 minus 12x equals 10 minus 18x. When I rewrote it, I wrote 40 minus 12x equals 10 plus 8x. So I'm going to go ahead and make this an 18. And when I add those together, I'm going to get 30 instead of 20. 18 plus 12 is 30. Okay, so I'm going to have to fix that there. So now I have 40 equals 10 plus 30 x's. Okay, so I apologize for that mistake. I have numbers on my variable side, so I'm going to add the opposite so I can move those over. So I have minus 10, minus 10. That goes to 0. So over here I have 30x left equals 30. Okay, I need to isolate the x or get the x by itself. So I'm going to divide by 30, divide by 30. This goes to 1, 30 divided by 30, so I have 1x. 30 divided by 30 is 1, so x equals 1. For number 10, x equals 1. Okay. Number 11, I'm going to rewrite and do it correctly this time. I'll double check myself. 4/5, I'm going to bring this up a little bit, x minus 8 equals 12. So double check. 4/5 x minus 8 equals 12. Okay. So I'm going to bring this up so we can see it a little easier. I'm going to draw my line here. this is going to be my number side, and this is going to be my variable side. Since my variable side is going to stay here, I'm going to leave this for a second, and I'm going to move the number over. And think about it. How do I move the number over? I have to add the opposite, right? So I'm going to add a positive 8 because negative 8 plus positive 8 is going to go to 0. 12 plus 8 is 20 equals 4/5 x. And it's a little bit tricky when we have fractions like this. So what I'm going to do is I'm going to multiply by 5/4. I'm going to multiply by the reciprocal. And when I flip that fraction and multiply by the reciprocal, I get 1x. Because 4 times 5 is 20, and 4 times 5 is 20. So 20/20 is 1x. Or you can look at, there's a 5 on top and a 5 on bottom, a 4 on top and a 4 on bottom, and they cancel. So however you want to look at that, this ends up being 1x. Okay. So this side over here, I'm going to take 20/1 times, this is what I multiplied, right? 5/4. So I multiply top times the top, bottom times the bottom, right? Numerators times denominators. So 20 times 5 is 100. 4 times 1 is 4. So x is equal to 100 divided by 4. And you might already know what that is because there's 4 quarters and a $1, right? 4 goes into 10 2 times. Subtract, bring down the 0. Okay, 25. So x equals 25. Okay. Let's go ahead and, oops, let's go ahead and write that in. X equals 25. And let's highlight that. Okay. Number 12 is a little bit interesting because they gave us the technical algebra terms for the reasons that we can do each step, which is really cool to think about. What law in algebra allows us to put things together or take things apart, because everything in math is ruled by these rules, these steps, these guidelines. So the first step says to distribute. So that reminds me, oh yeah, I'm going to distribute first. So there's 2 things to distribute here. There's parentheses here. There's 11 right next to these parentheses. So that's going to tell me to multiply by everything inside the parentheses. And the 6 is outside of these parentheses. So that's going to tell me to multiply by everything inside the parentheses. So for step 1, I'm going to distribute that. So 11 times 3 is 33. 11 times minus 6 is minus 66y, plus, and then I'm going to distribute here. 6 times 10 is 60y. Sorry, that's a 60y. Plus, and then 6 times 1 is 6 equals 9. Okay. Step number 2 says combine like terms, and in parentheses they put variables. So I look for terms that have the same variable with the same exponent that I could add together. And I have a negative 66y and a positive 60y. So since the signs are different, I'm going to subtract them. So 66 minus 60 is 6. It's going to be minus 6y. So minus 6y comes from those two. So 33 minus 6y plus 6 equals 9. Okay, that would be that step. The next one says combine like terms, and in parentheses they put constants. And remember, constants are our numbers. Okay, so we have 33 and we have 6 on the same side of the equal sign. We can't add the 9 because the 9's on the opposite side of the equal sign. We can only combine things that are on the same side. So 33 plus 6 is 39 minus 6y. I still have that. So those two combined together equals 9. Okay, so the last 2 steps are going to tell me to add the opposite or then do the opposite of the multiply or divide. So first we're going to add the opposite for our numbers. So we have 39, so we're going to do plus 39 plus 39. Oops, I shouldn't have written it that big. Hang on one second. Okay, so to figure out, because I wrote in my box there and that's not what I should have done, I'm just going to put this piece of paper here and know that I'm going to minus 39 minus 39, right? So if I go minus 39, that goes to 0, and I'm going to go minus 39. The signs are different, so I'm going to subtract. 39 minus 9 is 30. So I'm going to have negative 6y equals negative 30. So that's what's going to go in this box. So let's kind of do that and put negative 6y equals negative 30. Okay. And I should have some white out. I shouldn't be writing in pen, but it's hard to see with the document camera and pencil, so that's why I'm doing this for you. So negative 6y equals negative 30. And then I'm going to do the inverse of the multiply divide. So to get this y by itself, right now it's negative 6 times y. I'm going to divide by negative 6. So that's going to make that y. And then negative 30, whoops, let me move this over. Negative 30 divided by negative 6. So it's going to be a positive, and 6 times 5 is 30. So it's going to go there. So y equals 30. I'm sorry, y equals 5. And that's going to be our final answer. We divided negative 6. Okay, sorry that that one's messy, but our final answer is that y equals 5. And it was pretty cool to get to see the steps written out like that. So, what was this, 2.1? 2.1 had to do with inductive and deductive reasoning, which is finding these patterns. And we always want to keep reviewing solving equations because that's going to help us in every other thing that we do. So hopefully this lesson made sense, and good luck on these. If you need help, let me know.